Hello, everyone. My name is Steve Dimig. I'm an experienced Python developer, DevOps engineer, and cloud automation engineer. I have 30 years industry experience. I'm new to freelancing though, so I decided to put together some videos as a portfolio to kind of show my experience, how I do things, and where my expertise is. So hopefully I could win some bids. That's what I've been aiming for. Okay, so today we're going to talk about ETL processes, extract, transform, and load. So I have a little sample app that I've been going through and running a couple exercises through it to show various things. And one of it is the main backend processing. It shows it as a ETL process, and that's what it is. So it basically extracts data from the YouTube data API, does a bunch of transformations on it. It turns it into nicely formatted data frames. And then the data frames are converted into JSON and returned back to the front end. And then that's used to display data on the UI. That's kind of how it works. So the whole, it's implemented as an ETL process, but I never got into details on how that was done. And here I'm going to get into some details. So here's the architecture. The front end is JavaScript and Vue, uses Vue widgets and things. So backend uses Python, Fast API for REST, which I went through before on some benefits that has. Natural language toolkit to do things like sentiment analysis, very helpful, very handy. Uses Google APIs to talk to the YouTube data API. Uses pandas, of course, for data frames. Uses Bonobo, which is a ETL Python ETL framework, and we'll go over what that actually is and does. Okay, so one thing a lot of these tools that do this type of thing, that do these ETLs, they use something called a directed acyclic graph. And if anybody remembers discrete math, that's what they are. It's a graph that has edges with a direction and contain no cycles, so they can't go back to some beginning state or anything like that. They just have like a step-by-step type of processing. The reason this is powerful is you can take that and split it off for parallel processing. So for computing, we're taking these mathematical things. I'm sure they have a lot of other mathematical nice things to them, but that's what's good for us is we can easily tell what we can run in parallel by the setup of the DAG, the directed acyclic graph. So it makes it nice for these type of tools for sure. And there's several of them that use them. So like I said, what they're useful for is representing dependencies. You can tell what node depends on another node, so you know what has to be there before a particular node has to execute, right? So all its dependencies are done prior to it executing. You can tell that type of thing. Workflow management, a big one that does this type of thing is Apache Airflow, a very popular tool, using to stitch together various services with Apache. A lot of people love that. I haven't used it a lot, but a lot of people really like it. And code optimization, so often used in compilers and different things, but then that's where the part that allows us to we can optimize and run things in parallel. That's where that comes from, is the code optimization part of it. So basically, you can use the DAG representation to determine which part of the pipeline can be run in parallel, therefore increasing our performance without having to actually write parallel code, either using multiprocessing or multi-threading. Those are difficult and tricky bits of code to write that can easily cause errors and can take a long time to get right. You get them right, they're very, it's very good, but it just may take a while. And it's good to have a framework that actually does it for you without you having to worry about it. Like I said, some examples: Dagster is a proprietary commercial tool, Apache Airflow, and Bonobo, like I said, that's one that we're going to look at. It's a Python-based ETL framework. So Bonobo, what is it? ETL framework, Python language, used for building data pipelines, used to, move and process data, grabbing data from one place, doing some stuff to it, adding some value added, and then putting it someplace else, either for like a visualization or some type of business intelligence, that type of thing, or other processes or other tools to use, right? A lot of times that's what you extract. You do an ETL, and then another tool uses that, right? So a lot of times that happens. DAG execution, it uses DAGs as its primary, execution way to execute things, way to represent things. So it uses DAGs for that. Its primary abstraction is a DAG. I mean, that's what you're going to be using when you're using Bonobo. And it uses those DAGs to set up parallel processing. So I specify a graph, I specify chains within it. I run the graph and it runs the chains in parallel. I don't have to do anything, I don't have to write any multiprocessing code or anything like that. It'll run those things in parallel for me, gather the data, marshal it, all that kind of stuff, transparently. So it's nice for that. Here's an example. This is the example of the tool that we use. So we basically grab search data. From that, we grab channel IDs that we use to look at channel information. We also grab comment threads from the search string for the videos we get back. We grab the comment threads and do sentiment analysis on them. So both of these things, right, they execute. You have to extract the data. You have to do a bunch of processing on it. They all take time. So when you can parallelize this, as you can see from this DAG, it's basically split in half. These top three run in one thread of execution, and these bottom three run in another. So we can, essentially halve the time it takes to run this process by using something like Bonobo and a DAG and something that'll run in parallel. Now, we can do that using multiprocessing or using multi-threading. Definitely, we can do that. I've done that plenty of times. But as you can see from the chain or the code here with the chains, it's really easy to write these things. You set up a graph, you have your chains of execution, like this is one, right? Extract data, transform data, store results, that's a chain. Extract comment thread data, transform comment thread data, store results, that's another chain. So we add those chains to the graph, we run it, and boom, it takes care of everything. Executes all these methods, it stores the results, and then later on after it's done, down below we call this transform data, and we combine the two data frames that these things generate into one data frame, and we return that as JSON data to the front end. So that's all done here in this nice little, I don't know how many lines that is, 10 or so. If it's a very small amount of code, a very powerful way to do things. And you can see the output here. It runs these things. When it's actually running, you can see that these are grayed out, like so you'll see when it starts running the search data, that'll be active, and then these others are grayed out, and then it'll run the extract channel data and the extract comment thread data in parallel, and then finally it'll come back and run the transforms. It's not it's totally done in parallel, and you can see that by the output of Bonobo. So it's a nice tool to use. Way easier to debug than, say, PySpark. So like if you had big data and you were really, that took a real long time to do, like overnight batch processes, you probably want to use PySpark. But PySpark is very difficult to use. It just is. It's very difficult to use. So this is much simpler and easier to use. If you have small to medium-sized jobs that still need scalability, this is the way to go. And as I said before, good luck. Whether we work together or not, I wish you the best of luck finding a developer or a freelancer to fill your needs. And I'm available anytime you may need me. I haven't got too many bids yet, so I'm really looking for a bid. I'll work at a reasonable price for sure. I'm just looking to establish myself as a freelancer. So thank you very much.